Hi everyone, and welcome to Pre-Calculus, Lesson 8.4, Plane Curves and Parametric Equations. Parametric equations can be a lot of fun because what they do is they let us define how x and y change using equations. So you'll notice in our first example, we have x equals this function and y equals this other function. So we're allowed to define a curve using two different functions. Now the variable that we generally use with this is t, mostly because t tends to represent time in these questions. And we call that the parameter. Okay, so these equations describe the motion or movement of a particle over time. And that's why, again, why we use t, because t tends to represent time. Now, it can also indicate speed and direction along with the path that an object has taken. So it's very interesting how we can use this, and it helps us a lot with problems involving physics. So let's see how to work with the parametric equation. So in example 1, they want us to sketch the curve defined by the parametric equations x equals t squared minus 3t. And y equals t minus 1. Okay, so you'll see I set up this lovely table right here. And all I'm going to do is pick values for t, put them in, and get values for x and y. Okay, so t is negative 2. Then x is going to be negative 2 squared, which is 4. And then minus 3 times negative 2. Negative 3 times negative 2 is positive 6. So this is 10. So I have an x value of 10, and my y value is going to be negative 2 minus 1. And negative 2 minus 1 is going to be negative 3. So I'm going to graph the point that is at 10, negative 3, which is right here. Okay, so now I'll do it again. I have negative 1 for my next t. Negative 1 squared is 1. Negative 3 times negative 1 is positive 3. So I get 4 for that. And then here for my y's, I get negative 1 minus 1, which is negative 2. So I have the point 4, negative 2. So 4 is here and negative 2 is right there. Now what I'm going to do is, as I'm graphing this, I'm going to connect this, and I'm going to put a little arrow on this showing the direction, because this was graphed first and this was graphed second. So I'm going to connect it with a curve and put a little arrow on it to show which direction I was going in as my t's increase. So you always want to make sure to start with the smallest t you want and then go up from there. So I'll put t as 0 next. I get x is 0 and y is negative 1. So I have the point 0, negative 1. So 0, negative 1 would be right here. Okay, and I can put another arrow on that. If x is 1, I get 1 minus 3 here, which is negative 2. And I get 1 minus 1, which is 0. So I have the point negative 2, 0, which is negative 2, 0 right here. Okay, now you'll notice that if the points are further apart, that means the object was moving very quickly as t increased, because this only increased by 1, but it's a very far distance. But here, my points are pretty close together, so I know the object is moving more slowly. So I'll do 2 next. When I put in 2, I get x is negative 2 and y is 1. So I get the point negative 2, 1, which is right here. So you'll notice that this curved around and came back. Okay, if t is 3, I get x is 0 and y is 2. So I have the point 0, 2, which is right here. If t is 4, I would get the point 4, 3. So notice it's coming back in this other direction now. Okay, and finally, this is our last point. I'll get x is 10 and y is 4. So I get the point 10, 4. And notice all these x values came from putting in my t into the equation that was given. And all of the y values came from putting my t into the equation that was given. So last I have 10, 4, which would be right here. And it's like this. Now notice what we do is we don't always put an arrow pointing in that direction at this end because it doesn't go in that direction. It comes from that direction. So sometimes we'll start off with a little arrow like pointing in the opposite direction than we're used to. Or you can just start with a point there. And at this final end, we can just put an arrow going in that direction. Okay, so that's how you graph a parametric equation. Now, what if you want to change this parametric equation back into a normal equation? Well, we can do that, and that's the next thing we're going to do. So I'm going to copy down those two equations I have. X equals t squared minus 3t, and I have y equals t minus 1. And we've been asked to eliminate the parameter. And what that means is it means write this just in terms of x and y so that there's no longer a t in your equations. Okay, so step 1 for eliminating the parameter is to solve the simpler equation for t. So I'm going to look at these two and I'm going to say which one looks like the easier one to solve for t in. And I'm going to say that it's this one right here. Y equals t minus 1. So I'm going to take that and come down here and I'm going to say, okay, y equals t minus 1. So to solve for t, I'm just going to add 1 on both sides. So this becomes y plus 1 equals t. So that's step 1. Step 2 is you're going to substitute into the other equation. So I'm going to take what I got here and I'm going to put it into this x equation everywhere I see a t. Okay? So in that equation, I have x equals t squared minus 3t. So I'm going to take this y plus 1 and I'm going to put it in for this t and this t. So that becomes x equals y plus 1 squared minus 3 times y plus 1. And then I'm just going to simplify this. So I'm going to square this part. You get y squared plus 2y plus 1. And I'm going to distribute this minus 3. So minus 3y minus 3. So I just multiplied in the negative 3 here. And the squaring pattern, in case you don't remember it, you square the first term. You do 2 times 1 times y to get this middle term. And then you square the last term. Okay, now finally what I'm going to do is combine any like terms I have just to write it in simplest form. So this is y squared plus 2 minus 3 is minus 1y, and 1 minus 3 is minus 2. So I've eliminated the parameter in that. Okay, so I'm going to have video 2 for you, so don't forget to come back for that, but that's the first 2 examples of this lesson.